How did the best tanks in World War II end up abandoned on roadsides while inferior Shermans rolled to Berlin? Subscribe to see how Germany's perfect tanks lost the war. Panzer I featured multiple variants with incompatible engines. OSF A used a Krupp M305 engine while OSF B mounted a Maybach N L38TR, requiring completely different spare parts and maintenance procedures. The suspension failed constantly under combat stress, yet engineers never simplified the design. Panzer II produced 9 variants from OSF A through L, creating a logistics nightmare. OSF C introduced a 140 Maybach engine requiring different parts from earlier models. OSF D and E featured Christie suspension and torsion bars completely incompatible with the leaf spring systems of earlier variants. OSF J added sloped armor that doubled production costs and time. Field mechanics couldn't interchange transmissions between OSF C and OSF F. Each variant required its own specific parts inventory, maintenance training and repair procedures. Panzer 35T started as a reliable Czech Skoda design. German modifications added heavier armor and equipment, increasing weight by 20% while final drives remained unchanged, causing systematic failures under the increased load. Panzer 38T produced variants OSF A through G that progressively added armor and weapons. Each modification increased combat weight on final drives designed for the original lighter specifications, guaranteeing premature failure. Light tank complexity was nothing compared to medium tank disasters coming next. Medium tanks lost the war through catastrophic variant proliferation and weight mismanagement that made logistics impossible. Panzer III produced 15 variants from OSF A through N with 3 incompatible weapon systems. Early variants mounted 37mm guns. Mid-production switched to 50mm guns requiring completely different ammunition storage, loading procedures and sighting systems. OSF N mounted a 75mm howitzer in a redesigned turret sharing no parts with earlier models. Weight increased from 15 tons with OSF A to 23 tons with OSF N. Final drives designed for 15 tons now carried 23 tons, causing systematic mechanical failures across all late variants. Heavy tanks lost the war through impossible weight-to-drive ratios and infrastructure incompatibility that made deployment impossible. Tiger I OSF E was the sole production variant, but constant running changes created incompatible sub-variants. Early production used rubber-rimmed road wheels while late production switched to steel wheels, requiring completely different spare parts inventories. The Maybach HL130 engine consumed 450 liters per 100 kilometers. The complex Alvar steering system required 2 hours of warm-up time in cold weather before TE tank could move. Weight reached 56 tons on final drives designed for 30 tons maximum safe load. Average final drive lifespan was 100 kilometers. Most Tigers were abandoned for mechanical failure and fuel starvation, not combat damage. Tiger II OSF B featured 2 distinct turret designs. The first 50 production models mounted Porsche's curved turret with a shot trap that deflected incoming rounds downward into the thin roof armor, a fatal design flaw. Remaining production mounted Henchel's flat turret, correcting the problem after 50 crews died from the engineering mistake. Weight reached 70 tons on final drives designed for 45 tons maximum, lasting only 50 to 80 kilometers before catastrophic failure. At 70 tons, Tiger II exceeded Bridge E weight ratings across Europe and couldn't navigate standard infrastructure. Most were abandoned intact when bridges collapsed or final drives failed. Ferdinand weighed 65 tons, mounting an 88mm gun behind 200mm frontal armor. The petrol-electric drive system failed constantly. Original production lacked machine guns for close defense. Later units were retrofitted with bow machine guns and renamed Elephant. At 65 tons, recovery was impossible when final drives failed. Heavy tank engineering was rational compared to super heavy insanity. Panzer IV produced 9 variants from OSF A through J. OSF A established the 18-ton baseline with short 75mm gun. OSF G upgraded to the long 75mm and added significant armor. OSF J removed the electric turret traverse system to save resources, forcing crews to manually hand crank the turret during combat engagements. Final weight reached 25 tons on final drives designed for 18 tons. The complex Alvar steering system required constant specialized maintenance that field units couldn't provide. Panther produced 3 main variants. OSF D debuted with transmissions that shattered under combat weight within days. Designed for 45 tons, combat-loaded weight reached 48 tons on final drives rated for 35 tons maximum. Average final drive lifespan was 150 kilometers before catastrophic failure. OSF A introduced interleaved road wheels that packed with mud and froze solid in winter, immobilizing entire units. OSF G simplified production but inherited all fundamental design flaws. Most Panthers broke down before reaching engagement distances. Medium tank engineering disasters were nothing compared to heavy tank catastrophes. Super heavy tanks lost the war by consuming massive resources while providing zero battlefield value. Panther was built on the Panther chassis and inherited the 150-kilometer final drive disaster. Weight reached 46 tons, mounting an 88mm gun. The interleaved wheels froze solid in winter conditions. Most Panthers broke down during transit to front lee ness, never engaging the targets their guns were designed to destroy. Tiger produced OSF-A and OSF-B variants weighing 71 tons and mounting a massive 128mm gun capable of destroying any target at 3,500 meters. Each Tiger consumed manufacturing resources equivalent to 5 Panthers. Only 79 total units were produced. Final drives failed catastrophically under the 71-ton weight. Most Tigers were abandoned during transit from fuel starvation or mechanical breakdown before ever firing their weapons in combat. Mouse produced 2 prototypes weighing 188 tons each. Final drives designed for 120 tons maximum carried 188 tons, guaranteeing immediate catastrophic failure. The Mouse couldn't cross any European bridge and required a snorkel system for underwater river crossings. Neither prototype fired in combat. One was destroyed, one captured. Production numbers reveal why German tanks lost. Panthers 6,000 units with 150-kilometer final drive life. Tigers 1,347 units with 100-kilometer final drive life consuming 450 liters per 100 kilometers. King Tigers 490 units with 50 to 80-kilometer final L drive life. Tigers 79 units. Mouse 2 prototypes. Each increase in engineering perfection decreased battlefield availability. German tanks defeated themselves through complexity over reliability, perfection over practicality, engineering excellence over combat reality. Which design flaw shocked you most? Let me know in the comments.